Alright, so 6.1, we're doing a refresh of Algebra 1. So we're going back to solving systems of equations, except I'm going to teach you guys some stuff with matrices and how you can solve these in your calculator as well. But first, I gotta actually refresh your memories. So, when it's in slope-intercept form, like number 1, this is your easiest kind of way to graph, just because everything you need is already there. So my y-intercept is up here at 4 for this first one, and my slope is up 1 over 3. And because I'm doing this on a smartboard, and I need a little bit more dots, I'm just going to add a couple in. So, start here. The biggest thing with solving systems is you need to make sure you actually use like a straight edge. Use your driver's license, use your student ID, use something to make sure it's straight, otherwise it's going to start looking like these weird drunken lines, and then you're never going to find your intersection point because they're all going all over the place. Alright, this one, like 1, down 2 over 3, 3, 9, now your answers for these are the coordinates where they intersect. Okay, that's your solution. So my solution for this one is at -3, +3. Okay. So all that work for just one stinking dot. Now for number 2, is that in slope-intercept form? No, it's in standard. But you can turn it into slope-intercept. All you got to do is get y by itself. So for this first one, I've got 2y equals -x minus 8. Divide everything, and I mean everything, by 2. So I get y equals -1/2 x minus 2. Start down here at -4, down 1 over 2. And then for this one, I've got -2y equals -3x minus 8, bless you. Divide everything by -2, y equals 3 over 2x plus 4. Intersection at 1. -4, -2. Easy enough? Alright, cool. That's your first homework. That's literally it. Alright, now your second homework, the one that's due on Tuesday, is going back over elimination and substitution. Okay? Might as well get that done, because literally otherwise we're going to take 3 minutes today. Alrighty? So for this we don't need any more graphs. But we're going to start off with elimination. Alrighty, ready? So with elimination, your entire goal is to add or subtract straight down to cancel out a variable. Okay? On these, your goal is to be as lazy as humanly possible. Alright? I'm giving you that permission to be lazy. Not lazy, it's efficient. Just get it done. So if I look at number 3, what letter is going to be the easiest one to cancel out? X or Y? Okay, W-H-Y. Like, why is it going to be the easiest? Right? Yeah. So you need one to be a different sign than the other. It doesn't matter which one, top or bottom. Okay? But what we're going to do is we're just going to straight up add these equations. So I've got negative x plus a negative 2x, so that's negative 3x. Positive y plus a negative y, those disappear, equals 12. Magic, right? Cancel out with negative 3. So x equals a negative 4. I'm half done. Now what do I got to do? Yeah, now I got to solve for y. Does it matter which equation I plug x is negative 4 into? Go with your easiest one, though. The one with the least amount of coefficients. So I've got negative 4 plus y equals 11. 4 plus y equals 11. Y equals 7. Alright, not so bad. Alright, they're going to get a little more complicated, but if you think in terms of like, with fractions, when you add and subtract, you need a common denominator. That's all you're doing with these. Alright, so if I look at number 4, which variable do I want to eliminate first? X or Y? Y? Y. W-H-Y. What do you got? Yep. Definitely do that. Can I just subtract it as well? No, you're dead correct. Also, there is no such thing as a negative 0, 0. Alright. You're going to get the same answer either way you do it, but you can subtract straight down. Alright, so I end up with 2x equals 0. What's x got to be? Yeah. So I'm going to show you the two special cases as well. You've got where both lines are the exact same, and then we've also got where they're parallel and they'll never intersect. Okay? So if I've got x is 0, I got to plug that back in. So it doesn't really matter. 10 times 0 is still 0. So negative 7y equals 0. What does y have to equal? There you go. Cool beans? Alright, we got some more. Oh, wait. Alright, now we good? Alright, so here's 5 and 6. Take a second, write those down. So ready for number 5? So if I'm looking at number 5, what variable do you think you want to get rid of, x or y? Pick one. Come on, somebody pick one. Let's get rid of x. So if I'm looking, I see an 18 and I see a negative 9. Well, I can turn that negative 9 into a negative 18. All I got to do is multiply that bottom row by 2, right? So when I do this, I'll actually work over to the side a little bit, because then I can keep my original function the way it was. And I'm just like, oh, okay, I just transformed it. 18x minus 4y equals -2. And then negative 18x plus 4y equals 10. The biggest mistake students will make is they will just multiply the 18 by the 2, or the 9 by the 2, and not everything else. You have to be consistent. Distribute all the way through. So what happens when I go to combine these? Yeah, they both cancel. So I'm left with 0 equals 8. Is that true? Okay. So this one's not true. So therefore we have 2 parallel lines. And if you have 2 parallel lines, will they ever intersect? Anytime you get 0 equals something, they're automatically parallel. What's up, Michael? 0 does equal 0, and that's the one we're going to see next. That basically means it's infinitely many solutions, and they're the exact same line. Okay. I made sure I gave you guys both, like the ones that are going to mess it up. So if I'm looking at this one, you can actually divide on some of these too. See how these numbers are kind of huge? All right, could I pull an 8 out of everything on top? So divide by 8, that gives me negative 10x plus equals 1. And what would I divide that denominator, or the second equation by? 5. See how when I divide them, they're the exact same thing. If you went to eliminate these, I'm going to change all the signs on that bottom line. 0 equals 0. All right, that's what you were asking about. What do I do when I see that? This means they're the exact same line. And therefore, we're going to have something called infinitely many solutions. All right. Now, I get really lazy, and I forget how many i's are in infinite. So you'll see me write it as an infinity sign, Ly, many. Algebra 1 kids always said uli many. Oh, weirdo. Alright, but those are your 2 special cases. These are the only 2 special cases we have. Alright, we've got 2 more problems and then we're done. So most of the time, students love elimination. They're like, elimination is my best friend. I just cancel the crap out. But there are two situations where substitution actually works better. Alright, so they are right here. So what do you notice about the two situations I gave you? Y is by itself on both of them, right? So these two both equal Y. So remember your transitive property from geometry? Watch everyone. Oh, no. Y equals this. Y also equals that. Can I set this equal to that? Call it a day. Yeah. Stop that. Do you guys need me to plug in to get the second half of it? Or you guys know that you need to do that now? Good. Just in case you need it for your notes, Y is negative 1. Alright. Number 8 is the second situation where substitution works out to your advantage, and it's because I know Y equals this, so I'm just going to replace that Y with all of that. Okay, literally substituting it in. And then for number 8, which equation would you want to plug x back into? First one or second one? Second one. Be lazy. Plug it in right here. So negative 5 plus 1 makes it or negative 5. That's it. We just did both of them.